This conference will now be recorded.
So, Deepa, we had started last day the third chapter in your textbook that is entitled as Motion in a Straight Line. So, motion in a straight line we had started already. We had already learned what is called displacement, what is called position, and some coordinates, what is called frame of references, and we have defined what is displacement and what is distance, etc. So, as a definition, on the last day, we have learned what is motion. Motion is change in position. Okay, change in position. This is called motion. So, change in position with respect to what? With respect to time. With respect to time. But we have not discussed about the rate of change of position. Rate of change of position with respect to time during motion. So to get this information, what is the rate of change of position with respect to time during the motion? So to get this information, we had to define few physical parameters like velocity, then speed, then acceleration, etc. So in this also we'll be learning what is called average velocity, what is instantaneous velocity, what is average speed, instantaneous speed, what is average acceleration, instantaneous acceleration. So all these will give you specific informations about the rate of change of motion. So these are actually our topic for the discussion today. Okay, so just before that, before I just get into this, we'll see how graphically we can represent motion of any object, or if an object is at rest graphically. So this is, see, this is position, which is denoted by x, and this is in the x-axis, this is time. So this is called position versus time curve. Position versus time curve, graph or curve. So this actually, whatever parameters we learn over here, whether it is velocity, position, displacement, then acceleration, etc., we'll try to find out some relationship with time and displacement. Like, we'll be just trying to represent them graphically. So graphical representation is very, very important. And there will be many numerical problems, many problems in your exam, including various competitive exam. So graphically, how to represent represent various type of motion. So this we'll discuss while discussing today's velocity, speed, acceleration, etc. But we had already learned what is position, displacement, etc. So in that we'll see in the position and time curve here, if see the graph here is parallel to the time axis. See, this is the line which is parallel to time axis. That means if suppose this displacement of the object, this is origin of the curve, and this is some 10 meter. This point, some O, so it is OA is 10 meter. Obviously, I can write as vector also. So 10 meter. Then, as time progresses, the displacement does not change. It is always 10 meter. So that means object is not at all moving. It is just sitting at this point O. Okay, this is how we can, in the position time curve, we can represent the state of an object which is at rest. Okay, now see this graph, you can look here, this is also position time curve. This is representing uniform motion. So what is uniform motion? Uniform motion is defined as that the motion of any object, if it is actually uh, in a straight line, and if the object is covering equal distance, cover an equal distance in equal time interval. Suppose this is 5 seconds. Okay, it is covering some 10 meter. Again, if I take another 5 seconds over here, then this will be then again another 10, so it will be totally 20. Okay, 20 meter. So if you look here, if I draw like this, you will get that in equal time interval the object is moving equal or covering equal distances. So this is in straight line again, and this type of motion is called uniform motion of an object. Uniform motion. So if an object moving in a straight line covers an equal distance in equal time interval, then the motion of the object is called as uniform motion. So uniform motion always will be a curve passing through the origin in position time curve. It is passing through the origin, and the slope will be actually, if you write this is theta, so tan, so this theta will be actually 45-degree always. Okay, this is uniform motion. So tan theta will be always 1. Tan theta slope will be 1. Okay, all right. So this is the state of motion we can represent graphically in position time curve. We'll see when we'll discuss velocity, we can draw velocity time curve, uh, and then acceleration time curve, or acceleration in the velocity time position time curve, velocity in the position time curve. How does they look? These are all we have to learn today. Okay. Okay. So let us now discuss a motion. Discuss a motion of a car. So suppose this car is moving in a straight line, and how is it moving? Moving along the x-axis, suppose, and you look, the car starts from rest. That's why when time is 0 second, then here in the graph, see, this is the position of the curve. Then slowly the position is increasing. That means it is uh, moving along x-axis slowly, and its speed is increasing till, see, it is just getting a speed up to 8 seconds. It is just speeding, actually pick up the speed. Okay, picking up the speed up to 8 seconds. Okay, then after 8 seconds, you look, if I just shift my y-axis over here and x-axis here, look up to this uh, more or less 18 second, sorry, till 18 second, it is an uniform motion. That means in equal time interval. See, if I just shift my axis here, you look, this is a curve which is passing through the origin, so it is uniform motion here. Uniform motion. Uniform motion, this portion. So after that, you look, when it reaches to 20, thereafter this becomes parallel to time axis. That means after 20 seconds, this actually what it does, after 18 seconds itself, it starts applying brakes. It starts applying brakes, and after 20 seconds, at 20 seconds it actually stops. Okay, so I'll just, maybe I'll just write the flow chart over here. Speed pick up during 0 to 8 seconds. Okay, then uniform speed or uniform motion. Uniform motion means it travels equal distances in equal time interval. So 8 to 18 second uniform. Then start applying brake or applied brakes after 8 second, 18 second, 18 second, and then you look. So after 18 second, the curve is actually not straight line. See, it should have gone like this, but it is not. Here it bends. So, and then it stops at 20 seconds. I hope you understand this curve now. And as time progresses further now onwards, after 20 seconds onwards, the curve is not moving, so it will be parallel to x-axis. The curve will be parallel to x-axis as I have drawn the red solid curve. Okay, so this is how we have to analyze position time curves, motion of any object. Here we have taken a car, nice car, which is uh, moving in this fashion. Okay, so you might be thinking, sir, you have given the topics velocity, speed, acceleration, etc., but you have started with this motion. Yes, we need to learn this or understand this, because we'll be, throughout our discussion, we'll be taking up this curve and we'll analyze the velocity, speed, and acceleration for this curve alone. Okay, now let us go to the velocity. As I told you that to know the rate of change, rate of change of position of an object with respect to time, we had to define physical quantities like velocity, then speed and acceleration. Okay, so now we'll see, even in the velocity also there are subtle difference, like average velocity and instantaneous velocity. Now we'll look what is the average velocity. Average velocity, when we are talking about average velocity, it is defined as the change in the position or displacement divided by the time interval in which this displacement occurs. What does it mean? It means, suppose an object is at x1 position at time t1, and the object is at x2 position at time t2. Then according to this definition, how we can write average velocity? Average velocity, this is bar, or sometime it is written in the angular bracket, or sometime it can be written as a average, like that. Okay, so this all actually telling you that the average quantity. Okay, I'll just stick to the bar. So average velocity is defined as the change in the position or displacement. So what is the displacement then? The object at t2, it is at position x2, and t1 position of the object is x1. So I can write the displacement as delta x is equal to x2 minus x1. And what is the time interval? Time interval is delta t. I can write time interval, and it is t2 minus t1. Okay, now what is the definition of the average velocity? Average velocity is defined as the displacement divided by the time interval. Okay, so I can write this as x2 minus x1 divided by t2 minus t1 as well. Okay, so this is called average velocity. And now let us see what is the unit of this average velocity. What is the unit? So this is actually meter, and this is in second, so it has unit. Average velocity has unit meter per second. Okay, meter per second. You have been learning this from your 8th standard, maybe, when you started learning what is velocity. And see, since displacement is a vector quantity, so velocity, average velocity, which I am writing as v bar, is a vector quantity. Vector quantity. Okay, so that means average velocity has both the magnitude and direction. And since it is a vector quantity, so average velocity v average, so average velocity, it can be either a positive quantity or a negative quantity, because, and even sometime it can be zero also. Vector quantity can be either zero, or a zero means null vector, or it can be a negative vector, or it can be a positive vector. So this depends on, because displacement can be either positive, it can be negative, even it can be zero. Suppose in a circular path, one person starts from here and then all the way it goes like this, and so if suppose it goes to B and then come back to again, come back to A again, so then it is having displacement 0, so velocity also will be 0. So Deepa, I have got a problem over here. My screen got frozen. So I'll just show you the slides, and then I'll go with the text. I'll just reshare my screen. Let me see if it works. Oh, Deepa, are you able to hear me?
Sir,
Are you able to hear me? Actually, my screen got frozen. I am just trying to do something over it, or shall I restart the meeting after 5 to 8 minutes? Can I like cancel the meeting now and then restart this? Will that be all right for you? Because otherwise I cannot show you, or I cannot actually, screen totally got frozen. I'm sorry for the inconvenience. It happens actually sometime. Technical fault. Deepa, I'll be back in 5 to 8 minutes. Okay, just be there in the line.
working, sir.
This conference will now be recorded.
So uh, we had started our discussion about motion in straight line, the third chapter in the last lecture, and we had already discussed few things. I'll just recap for uh, your sake. See, we had already learned what is displacement in the previous lecture, displacement, and what is distance, what is before that, what is position, and then reference frame, etc. we have learned. And most importantly, what we have learned is the definition of motion. The definition of motion is change in position or change of position of an object with respect to time. Okay, so that we had already learned. But what we had not learned is what is the rate of change of position. We have seen that motion is defined as change of position with respect to time, but we don't know what is the rate of change of position with respect to time. So today we'll be discussing this, and to discuss this or to know this rate of change of position with respect to time, in physics we had to define three parameters, which are velocity, then speed, and acceleration. Okay, so these are the terms, or these are the topics for discussion today in this class. So before I get into this directly, let me just tell you the graphical representation of an object or a state of motion of an object. See, in this, this is your vertical axis where I am plotting position, and in the horizontal axis I am plotting time. So anything in motion, any parameter in motion can be represented graphically, can be represented graphically. So that graph can be position versus time, or that particular parameter, suppose velocity versus time, or acceleration versus time, like that. So our knowledge will be concrete if we see the curve, position time curve, or velocity time curve, or acceleration time curve, or sometime the parameter, suppose in position time curve itself you can show the variation of velocity, acceleration, etc. Okay, so in this case, you look, what I am trying to say is I'm just trying to discuss the state of motion of an object in the position time curve. See, what does this mean? Suppose this is the origin and this is a point OA. So this is OA distance. The object is initially at OA distance. Suppose this is 10 meter. Now as you are spending time, or if your time is increasing, along with that, the displacement or the position of the object is not changing, or the displacement is not there. So here displacement is 0. That means your initial position, here it is final position, both are at the same place. Okay, so displacement here 0. What does this mean? If the displacement 0, that means the object is at rest of its motion. Okay, it is at rest, it is not moving at all. But now here you look here, I am plotting again position time in a position time curve. I have this line. What does this line? See, it is just going through the origin. It is straight line. It is going through the origin. And see, actually this is saying that if you just look, the slope of the curve is throughout the same. If this is theta, so theta is, if this angle is theta, theta is throughout. That means your slope, you can see this, most likely it is tan 45 degree is equal to 1. So it has slope 1. So this means actually the object in motion is moving an equal distance in equal time interval. So what does this signify? This straight line which is passing through the origin, this signifies that the object is covering, first of all it is moving in a straight line, and it is covering equal distance in equal time interval. Okay, and that's why this motion is called uniform motion. Uniform motion. And if you have this in the velocity time curve, so then we can say the object has uniform velocity. Uniform velocity, that will look when we discuss the velocity, acceleration, etc. Okay, now let us take, let us consider motion of a car. See, suppose this car starts from rest, that means initially the velocity was 0. That means it starts from origin. If it starts from origin at t is equal to 0, x is equal to 0, its position is at origin. Now see, the motion of this car is actually represented by, suppose represented by this car, this curve, sorry, this is position time curve which is representing the motion of this car. So this curve, from this curve what you can say is that the car is getting speed up, getting speeded up to, or picking up a speed up to 8 seconds. So 0 to 8 seconds. In this time interval it is getting a speed or picking up a speed. Then see, from 8 to 18, just draw a line over here. Look, if I shift my origin from here to here, look, this curve is actually going through the origin and it is a straight line. So this I can tell that this is uniform motion, this portion. So uniform motion, that means it is moving equal distances in equal time interval. Uniform motion, which time interval? Here the time interval is 8 to 18 seconds. Okay, 8 to 18 seconds. Now look, after 18 seconds this car starts to apply brake after 18 seconds, and when it is 20 seconds, you look here, it is here. So So that's why after 18 seconds, the curve is not straight line further. Okay, it is not further straight line. Otherwise, it would have gone like this. So it has a curve over here, and when it reaches to 20 second, look here. This 20 second, thereafter the curve is straight line like this, which is parallel to your time axis. That means with time, the position is not changing. So within this time interval, say at 20 second, exactly at 20 second here, the car stops, and thereafter it doesn't move. It is at rest. So this car, look here, I'll just remove this portion alone. Then you can analyze by yourself. Maybe I'll repeat for your sake once again. So up to 8 seconds, the speed is increasing. Then after that, it is moving uniformly. That means at equal time interval, equal distance, it travels up to this portion, this time interval. And during this time interval, it stops after 18 second to 20 second, and further it is at rest. Okay. So you might be thinking why I'm telling about this curve, because we will be analyzing this curve all the way while discussing speed, velocity, acceleration, etc. So let us go to our main business today. So this is average velocity. What is average velocity? Average velocity is defined as the displacement divided by time interval, or change in position divided by time interval in which this displacement occurs. So if I just explain bit, you will understand again. See, suppose an object is at x is equal to, it actually at x1, suppose position x1, suppose the object is moving in a straight line along the x-axis. Okay, at certain time interval, suppose this is time interval t1. Okay, sorry, this is x1 position, and it actually it is at time t1, and another time t2, it has a position x2. So object is at, so this is at t1 and x2 at t2. So according to this definition, the average velocity will be displacement. Okay, I'll write in words. Displacement or change in position divided by time interval. So what is displacement? We can write from here x2 minus x1, and what is the time interval? t2 minus t1. Okay, because we know at t1 it is x1, position is x1. At t2, after some time t2, its position is x2. So what is the displacement? Final position minus initial position. So this is delta. This can be even written as delta x displacement, and this can be written as time interval. This is written as delta t. Okay, this is actually the definition of mathematical expression for average velocity. So this is bar. This bar sign actually is telling about the average of this quantity, or in other words, average quantity can be denoted by bar. Okay, sometimes it can be written even in angular bracket, or also sometimes it can be just simply written in the suffix average. Okay, v average or vf in short. So we'll be sticking to the bar for denoting average here. So this is your average velocity. Now we'll try to interpret this just by knowing the unit. See, this is actually having unit. This is meter and this is per second. So it has unit meter per second. Okay, meter per second. So as the displacement is a vector quantity here, so the average velocity also a vector quantity. I hope it is not an issue to understand. So it is a vector quantity. Why? Because the displacement is a vector quantity. So if that is a vector quantity, that means it has both its magnitude and direction. And also we have learned that displacement can be either positive or negative, and sometimes it can be zero also. So does this average velocity. Average velocity can be positive, can be negative, even can be zero. Okay, because this is a vector quantity and related to displacement. Okay, so this is your average velocity. Now if we want to graphically interpret, see, this is the motion of the car which I showed in the beginning. Okay, I will try to find out average velocity for this car and try to represent graphically. Let us see if we draw this curve in a magnified form up to 8 seconds. See, if up to 8 seconds, if I magnify this part, if I magnify this part alone, what you see is this one. Okay, this is the magnified figure of this curve itself, and it is up to 8 seconds we have magnified. Okay, up to 8 seconds. Now we'll see how to define average velocity geometrically and how to define average velocity according to our mathematical expression v average is equal to x2 minus x1 divided by t2 minus t1. Let us find out the average velocity for uh, the car in the time interval. This interval 2 seconds between 5 second and 7th second, 5th and 7th second. Okay, so if you want to calculate, see here your t2 is, so we are trying to calculate average velocity between these two time, like t2 is 7 seconds and t1 is 5 seconds. Okay, now you look, we have to find out, so I know what is the time interval here, t2 minus t1. So t2 minus t1, time interval will be 2 seconds. Now we have to find out x2 minus x1. So x2 means what? The position of the object at t2 time. So t2 is 7 seconds. What is the position here? Look, this p2 is the position. If you look carefully, this has a value 27.4. So what is, I'm just writing here, this is x2 is 27.4 and minus p1. So t1 is 5 seconds. So you look, this is the point position of this car at this particular second, 5 seconds. After 5 seconds, so this is 10. X1 is 10. Now if you divide with the time interval 2 seconds, so you have here 17.4 by 2. Okay, so you'll be able to find out the value for this in this out. So essentially you can see geometrically, so what we have got here, we have got this average velocity as x2 minus x1 by t2 minus t1. See this particular thing here, you see x2 is p2 position of the car at time after 7 seconds, t2 is 7 seconds, and after 5 seconds the object is at this p1 position. Now what does this average velocity meaning? It is delta x by delta t. This means the slope of this curve. This means the slope. Geometrically it means average velocity means the slope of the line p1 p2. Okay, the slope of the line p1 p2 in this curve. Okay, that means if you know the final position, if you know the initial position, and then connect them, you get a line that is a straight line here p1 p2, and the slope of that straight line will give you the average velocity over here. So here see geometrically average velocity in between 5 and 7 seconds is the slope of the straight line p1 p2. So average velocity will give you the slope of the straight line joining the two positions of the object between which you want to calculate the average velocity. Okay, now we will see that the average velocity, since it has displacement on the top, average velocity displacement, or I'll write in terms of delta x by delta t. This is displacement. It can be positive, as I said, it can be negative, it can be even zero. See, these curves are actually drawn in the position time plane. So this is the position, this is the time. So this curve is showing that the positive slope or positive value of the average velocity of the object which is moving along the x direction in a straight line. So this shows the positive slope. Okay, positive slope. Whereas the second curve, you can see this has negative slope. Negative slope. Okay, if you just, this is the angle. So this is having actually a negative slope. So this gives you average velocity negative, and this gives you average velocity positive. Okay, and in this case, you know, displacement is zero over here because it is at rest. The object is at rest. So if this is zero, obviously average velocity will be zero. So these are the curves, Deepa, you need to carefully note. In your exam there will be curves like this, and then they will ask you which one is representing what. Okay, there will be many curves like this. We'll be analyzing, and I'll be giving few quizzes, and maybe we'll take up few numerical examples on related to these curves also. Okay, do you have any doubt over here? What is average velocity? What is the geometrical representation of the average velocity regarding this thing? If you have any doubt, you can ask me now, or else I'll proceed. Shall I proceed? Okay, I'm not getting your response. Maybe I'll proceed then. So now we'll be learning what is average speed. So you might be thinking, sir, suddenly you have brought, see, you told that we'll be discussing velocity. Suddenly you have brought average velocity. Then you are now bringing average speed. What does it mean? Actually, average velocity is telling you the speed during an interval. During an interval, the velocity during a time interval, as I showed you in the curve. This is called average velocity. okay, or average change in the position of an object with respect to time. Now we know that not only displacement, we have learned even total path length also. When object is in motion, object can change its position. Okay, I'm telling that the motion is change of position with respect to time. So we have seen that object can change its position in two ways. One is it can just travel in the straight line without making any change in the direction. But we had again seen one object is going O to P, then P to Q, and then it comes back to P to Q to P. So it goes from O to Q directly, suppose, and then comes back Q to P. So in this case, there is a difference between the displacement and path length, or the total distance the object travels, right? But here also change in the position is happening. So we can get rate of change of position in this case also. Rate of change of position in this case also we can get. But in this case, since it is changing its direction, displacement displacement is not same as distance, the path travel. Okay, distance of the path traveled. Okay, so then rate of change of this distance and displacement also will not be the same, right? That's why we had to define another quantity. See, in the previous slide we had discussed average velocity, which is related to displacement. But now I have got another term related to change in the position, that is distance or path length. So if we just want to see the rate of change of this distance or distance or the total path length over a time interval, then it is not the same as the displacement over that time interval. Okay, these are not the same. That means your average velocity is not equal to this quantity. So we'll be defining this quantity as average speed. I hope you understand what is the basic difference between average speed and average velocity. Why we are bringing another term, average speed. Even though we have average velocity, we are bringing average speed because when an object is changing its direction during its straight line motion, the displacement and the distance or the path length it travel is not equal. Okay, path length is not equal to displacement. So in that case, we have to define average speed. Okay, average speed. So this also defined like denoted by V sometime, and you can give the bar average speed. It is actually defined as the total path length that the object travel. So the total path length or the distance traveled by an object divided by the total time interval. Total time interval. Time interval during the motion. During the motion. That will give you average speed. Okay. Alright. So this is average speed. So this quantity, since see this is the total path length and this is a scalar quantity. This is a scalar quantity. So obviously this average speed will be a scalar quantity. A scalar quantity. So if this is a scalar quantity, and scalar quantity always is positive, always positive, it will be always positive, always positive quantity. It cannot be negative, even it cannot be zero. It cannot be zero also. It cannot be zero is not possible. Okay, because path length is not going to be zero at any time. So average speed cannot be zero or cannot be negative. It is always positive. So this is the difference between average speed and average velocity. Average velocity is a vector quantity, and average speed, here we have learned that this is the ratio of the total path length divided by total time interval, and path length is a scalar quantity, so average speed is also a scalar quantity. Okay, average speed is a scalar quantity. But see, if we just take a uniform motion along straight line, uniform motion along straight line, and when, so I'm just talking about uniform motion along a straight line. Straight line, I'm just abbreviating as ST dot line without any turn, without any turn. Okay, if this is the case, see the displacement will be, see if the object is at t1, suppose at t1 it is x1, t2 it will be t2, at t2 it will be x2, at t3 it will be x3, like that the object will be moving, okay, in a straight line. Since it is not turning, not taking any turn, the displacement delta x and the path length or the distance will be same. In that case, magnitude of average velocity will be equal to average speed. So during a uniform motion along straight line without any turn, the magnitude of the average velocity will be equal to the average speed. Okay, so this is another special case. All right, so now Deepa, is it audible to you?
Yes, sir.
Okay, good. Now we can actually draw some, I have already discussed this, we can draw some uh, contrast between average velocity and average speed. This is a vector quantity that we have learned already. Okay, this is a scalar quantity, scalar. Okay, we have seen that vector quantity means it can be either zero, it can be positive, even it can be negative, but this will be always positive, positive always. Okay, it cannot be zero or negative. See, in general, see average velocity is less or equal to average speed. Okay, average speed in general, and this in general, average speed, this is speed, is greater or equal, so equal will be in uniform motion, as I said, uniform and straight line motion without any turn. Okay, this is third point. Okay, it will be in general greater than the average velocity. Okay. So these were few contrast between both of them. Now we'll just go to another term called instantaneous velocity or simply velocity. The velocity we know in general the velocity we know is actually instantaneous velocity. Velocity we know is called is not called is actually the instantaneous velocity. Instantaneous velocity, I'll define it. Velocity. So instantaneous velocity is written simply velocity also, and it is as usual denoted by v like this. Small v, sometimes people write capital V, sometimes people write u also. U for initial velocity and this for v for final velocity. Okay. Now look, what is instantaneous velocity? We'll define that velocity. Instantaneous velocity of an object at any instant of time. Okay. It is defined as the limit of average velocity as the time interval delta t becomes infinitesimally small. Okay, before I go to the definition, let me tell you why do we need this instantaneous velocity and what is this instantaneous velocity. I have I have told you that the velocity means actually change in the displacement or change in the position divided by time. Okay, that is a kind of definition in general. But we have already learned average velocity. Average velocity, it was giving the information. So average velocity was giving, so v average gives information about the rate of change of position during a time interval. Okay, it gives the rate of change of gives the information about the rate of change of position during a time interval. But in that case we don't know what is happening at each instant. Then what is happening? How does position change, or what is the rate of change of uh, position at each instant? So what is happening at each instant of time? You might be having some problem with this term instant. I'll just define that. See, when I tell 5 seconds, that means I just talk about the motion of the object or the rate of change of position of the object from 0 second to 5th second. So this is an interval. This is an interval. When I say the speed or average velocity, then it is related to an interval. So when I say 5 seconds, then it includes 0, 1, 2, 3, 4, and 5. That means first second, second second, third second, fourth second, and fifth second. These all are included in 5 seconds. what is this second? See, first second means only first, that interval, that instant. This is actually called instant. See, second or third, these are actually only that particular interval. If I say fifth second, that means just fifth second, not more than that. Okay, just at the fifth second, what is happening at fifth second? This is called instant. When I say 10 seconds, so it seconds, it includes all 0, 1, 2, 3, 4 up to 9. Okay, up to 9, and then it will come 10 seconds. Okay, but when I say 10th second, that means these all are actually excluded. Only this is the interval. Okay, this 10th is the interval alone, this one alone. Okay, this alone. 10th means only one particular instant. That 10th. Okay, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these counts are coming in 10 seconds. But when I say instant, then 10th, that particular instant is called instantaneous. Actually, that is the instant, that is called instant of time. Okay, all right. Now let us try to define the instantaneous velocity. So instantaneous velocity is defined as the limit of the average velocity when time delta t tending to 0. That means it becomes very small. Interval becomes very small. And mathematically it can be written as this limit. So v instantaneous velocity, it is written as limit delta t tending to 0 delta x by delta t. This can be written, if this is tending to 0, in the language of calculus, it can be written as total derivative dx by dt according to calculus. So hereafter, whenever we talk about instantaneous velocity, we'll be writing dx by dt. Okay, mathematically this is. But what is average velocity? This is del x by del t. Okay, change in the position divided by time interval. But here this is the definition of instantaneous velocity. This is called simply velocity or instantaneous velocity. Okay, this is instantaneous velocity. So what it gives, actually it gives you the information at each second. If I say the position of an object is changing like 0.4 t square as 0.4 t square and 5t, like this, the position is changing, then you have to find out what is the instantaneous velocity, or simply if they ask you to find out what is the velocity of the object at 4 seconds. Okay, 4 seconds, what is the velocity, what is the velocity at 4 seconds? Okay, that means you have to find out instantaneous velocity. What you have to do, you have to take derivative with respect to time. So it will give you 0.8 into t plus 5. Now I have, so t is 4, you have to put it here, t is 4. 4 means it will be 3.2 plus 5. So this is velocity at t is equal to 4. So this will give you 8.5 meter per second. Okay, meter per second. This is your instantaneous velocity. Okay, if you are asked to find out the average velocity, then you have to find out, see, for 0 what is the velocity, what is the velocity for your, like, see, you can just write what is x. So x at 0, that is 0. X at 4, x at 4 will be 4 into, this is 16 plus this is 20. So you'll get the x2, this is x1 and x2, you get that. Okay, So it will be 6.4. So this is 26.4. So average velocity for that same thing will be, this is, sorry, 26.4 divided by time interval means 4 second minus 0, that means 4. So it will be 26.4 by 4. This will be your average velocity. Okay. So Deepa, as I know you have class at 6 o'clock, you have to prepare for that. I'll stop it here today. Next day I'll start from the graphical representation, and with a recap of this instantaneous velocity and acceleration part we'll be discussing on the next class. Okay, and maybe we'll try to take up few more numerical examples on that. Okay, I'll stop it here now. Is that okay?
Okay, sir.
Okay then, bye.